Hi everybody, this is Professor Millman and I'll be going over review for Module 3 exam. It covers topics of statistics, probability, and a little bit of normal distribution and empirical rule. So let's get started. Alright, so question number 1. There's an equal chance that a coin will land on heads or tails when flipped. What is the theoretical probability of flipping coin 3 times and getting tails each time? Okay, so there are 2 ways to answer this question. You can go ahead and list all of the possibilities. So for instance, you have 3 coins. One could be heads, the other one can land tails, and then the other one can land on heads. So that's a possibility. And the total number of such possibility is many. Well, if it's only one coin, it's either heads or tails. There are 2 possibilities, correct? Only 2, so 2 possibilities. So probability is 50-50, whether it's heads or tails. That we know, that we're comfortable with. When there are 2 coins, your pool of possibilities grows much more, because then you got heads. Let me just, instead of drawing circle, I'll just write down the possibilities. So you can have heads, you can have heads tails, you can have tails heads, or you can have tails tails. So you have 4 different possibilities. And then we can write the theoretical theoretical probability by doing the number of successes divided by the total number of outcomes. For instance, in this case, probability that you're going to have 2 heads is 1 out of 4. Okay, here probability of 1 head is 1/2. Probability of 2 heads is going to be 1 out of 4, right? There's 1 chance out of 4 different equal or likely possibility. When there are 3 coins, right, as in this question, then writing out possibility becomes a little bit longer, but it's still possible. So for the 3 coins, I like to do it this way. I like to write the possibilities for 2, like this. And then I attach the 3rd coin. Let's say the 3rd coin ended up being all tails. I'm going to put it in front. So that gives me the 4 possibilities. And then I'll get another 4 possibilities if one of the coins, the 3rd one, ends up being tail here, ends up being heads. So altogether we get 8 different possibilities. You see, 8 with the 3 coins. You've seen this in class, and this idea that once you increase 1 more coin, the number of possibilities actually doubles. You see, times 2. So if it's 4 coins, it will be how much? Yes, 16. And then 32 possibilities, and so on. So probability that you have 3 coins in this case, 3 heads, I'm sorry. There's only 1 chance for that out of 8, which gives us the answer of 12.5%. Divide 1 by 8 and multiply by 100. That's where you're going to get 12.5. Doing this is extremely long, and it's not advised. You don't have to do this. This is when you're learning this for the first time. When you see it for the first time, you have to go through this process to feel it for yourself, that once you add additional outcome, another coin, the probability diminishing, it becoming smaller. So instead, we have something that's called a multiplication rule of probability for independent events. When you have probability of A and B happening, and when one coin does not influence the other, what you simply do, you just multiply those probabilities. So in this case, if you want to know what's the probability that you have heads after heads after heads, you multiply probability of the event of getting 1 head, and you multiply it 3 times by itself. So it's 1/2 times 1/2 times 1/2. And that gives you the answer immediately to be 1/8. You see it? You multiplied 1/2 3 times. If it's 4 coins, 1/2 times 1/2 times 1/2 times another 1/2, and so on. Keep that idea in mind as we go through some other questions that will also deal with the more than one event, where the events are independent, and you do not expect any dependent events in this class. Everything that was covered in the lessons in Modulus 3, we never talked about dependent events. This is not a course in statistics or probability. So that's the most you would be required to do. Okay? Alrighty, let's go to the next question. A die has 6 faces showing a different number of dots from 1 to 6. If a die is thrown, what's the probability of a rolling number less than 6? Less than 6. Two ways you can answer this question. You can think about, okay, what are their numbers less than 6? Well, there are 5 numbers, okay, out of 6 possible chances, and that's it. You got your answer of 83.3%. Just divide 5 by 6 and multiply by 100. You get 83.3. Another way you can say, well, if probability of getting a 6 is 1 over 6, that means the rest, which is 5 out of 6, is the answer. Regardless, I think it's similar way anyway. Just understand what the die is. It's 6 different possibilities, and each one is equal or likely. And just go ahead and answer whatever. You count the successes. There are 5 successes. I like to think of a probability defined classically, probability of some kind of event. I like to do it like that: success, or chances for success, divided by the total possibilities. Right, so there are 6 possibilities and there are 5 chances for success in that question. So here it goes. Question number 3 is talking about a 52 regular deck of cards. I decided to put the deck of cards here for you so you could see them again. We have done this in class, but I'm noticing that through the years, it seems to be that not everybody are familiar with the standard deck. So take a look at this picture right here. So there are 52 cards in the standard deck. We have something that's called suits. There are clubs, spades, hearts, and diamonds. There are 13 of each kind. All right. There are 3 face cards within a deck times 4 different suits. There are 12 face cards overall. There are 4 aces. And the rest are number cards. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 number cards from 2 to 10. And that's a standard deck. Okay, so when you're answering questions, be familiar with it. Okay, just help to visualize it. Oh yeah, there's also half of the cards are red and half of the cards are black. Alrighty, so now let's go ahead and we'll see a couple of questions that deal with playing cards. So let's do question number 3. A card is drawn from a regular deck of 52 cards. What is the probability that the card is a king or queen? It's an OR event. Okay, so when you do an OR event, it's an addition rule. So you're simply counting successes. So probability of a king or queen. So it's probability of king plus probability that you have a queen. So you just simply, do you see when you have an OR connective here, the OR is more flexible. OR means this or that. That's what we count the success. That's why we're adding them together. Okay, now the full addition rule of probability states that if there is an overlap, you don't want to double count the same thing twice. So you subtract the possibility that you get king and queen at the same time. Now, for this question, we don't have, king and queen. Here's queen. Don't have space to write the queen. But this is not possible. This is 0. It's not possible to get a card that's both a king and queen at the same time. But sometimes it's possible to get something like king and a diamond at the same time, right? King of diamonds. So we do need to, when we do this, to ask ourselves, are these overlap? We're going to see some questions later on that we do need to take care of that. But for now, we're counting success for kings out of 52 cards, for queens out of 52 cards. You can just add them right away and put it under 52. Alrighty, and then just simply reduce this. So divided by 4, so you get 2 over 13. reduce the fraction. And that makes sense because there's one king and there's one queen within one suit. You see it? So it's 2 out of 13. Let's move on. Question 4. There are 14 blue marbles, 25 yellow, 18 pink. One marble is selected at random. Find the probability that the selected marble is not pink. This is a classical event. There's only one marble that we're looking at, so we just simply need to count our successes. So not pink. How many not pink marbles we got? Well, it's 25 and 14. Yellow and blue, so that gives us 39 out of the total of 57. And then once you do division, okay guys, at this point, once you get a fraction, don't mess it up because you just need a percent. Divide 39 by 57 and multiply it by 100 and you'll get it 68%. All right, you shouldn't be at this point have difficulties of converting a fraction into a percent. Simply divide. There's no need to set up any proportions, no axis, nothing like that. Just divide, get a decimal, multiply it by 100, and you got your result. Okay? Be confident with that. Next one. In a 2-child family, the first child is a boy. What is the probability that the second child is a girl? If you remember from a lesson, we had a very identical question. The two events are independent. All right, so it doesn't matter whether the first child was a boy or girl. There's always 50% chance that, you know, whatever biological gender would be for the next child. So it's 1/2, 50%. Okay. If the question was, let's say someone is having fraternal twins, what's the probability that both of the children end up having a biological gender of a male? So there, each one is 50-50, but once you write the possibilities, you're going to have male, 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 female, female, male, or female, female. So possibility for male, male combination will be 1 out of 4, or 1/2 times 1/2, which will give you 1/4. But we're talking about fraternal twins. That means 2 children. Here, it's talking about 1, and 1 probability is 1/2. Okay, so don't get confused here. Look at the question. Is it talking about 1, or is it talking about 2, or is it talking about many? Right? Read the question carefully. For instance here, a single 6-sided die is rolled. What is the probability of rolling 2 or odd numbers? So there's only one die, so you just need to calculate a classical probability by calculating the successes. So it's either 2 or odd. Again, it's an OR that is used. So let's write down the possibilities. So we got 2, an odd number. We got 1, 3, and 5. Okay? So there are 4 out of 6 possibilities, which is 2 out of 3. Does that make sense? 2, 1, 3, and 5. Notice 2 is not an odd number. Okay? I just want to do it on the side here so you don't get confused. If it was a question, let's say, P, probability that it is 3 or odd number. This has nothing to do with this question. It's just something else. Something similar, but I want to illustrate the point. So if it was 3 or odd number, notice there is 1, 3, and 5 that fits that category, correct? But you see how 3 is already odd? So when you're adding it, you're not going to make it 4. There are only 3 numbers that fits that category out of 6, which is 1/2. So what I'm saying is, when you do an addition rule, you do not count something twice. So you don't say, oh, I got 3, and then I also have 1, 3, and 5. So there are 4 chances. No, because 3 is an odd number. Read the question carefully and say, okay, how many successes I got? I got 3, and I got odd numbers. So the possibilities are 1, 3, 5, which is 3 possibilities out of 6. That gives me the answer of 1/2. Again, it's not question 6. Question 6 was 2 or odd number. So there are 4 possibilities out of 6, which gives us the answer of 2/3. Here's another card. question. If one card, 1, is drawn from an ordinary deck, what's the probability that the card will be an ace on a diamond? I like that question, all right, because that's similar to what I just showed you with the 3 or odd number. So probability that it is an ace or a diamond. Okay, so you can think of this visually by looking at all the playing cards, and you can see, okay, I got 1, 2, 3, 4 aces, correct? And then I got 13 dimes. I come back. I just want to make it big like this, right? So, and then you got 13 diamonds. But you see, this card right here is already being counted from the aces. So if you do 4 plus 13, that would be wrong because you're counting ace of diamonds twice. So it's 13, you see, 13 like that, and then additional 3 of the other aces. So that gives you 13 plus 3, which is 16 cards rather than 17. Do you see it? Make sure that you see it and understand that there's an overlap. So you can count it in your mind and say, okay, what is the success? I got 13 diamonds, good, and you got 4 aces, but one of them was already counted. So you get 16 out of 52, which will be your answer. That's one way you can answer that question. Let's write that down right here. So right away, we got 16 out of 52, which reduces to, what does it reduces to? Reduces to 4 over 13. Divide both sides by 4, or look at the multiple choices, use your calculator and see which one gives you the same decimal. All right, your answer on probability could be either the fraction, decimal, or percentage, okay? So you got to be comfortable with all three. But remember, when you divide numerator by denominator, that's when you get your decimal or your percent. Okay, so now the other way to count this is to do this using addition rule. So you do probability of ace plus probability that it is a diamond minus probability that it is both an ace and a diamond. That's where you're subtracting the overlap. 4 aces. I'm going to put it all under the same denominator because it's the same deck. So 4 aces, 13 diamonds, 17, and then minus that card, which is ace of diamonds, which we got to subtract because we already counted it here, and you counted it in here. You use the same card twice, so you have to subtract the overlap. I'm not forcing you to do it this particular way. You can do it this way as well, but in your mind, you have to see what are you counting. Alrighty, question 8. A box contains 4 glazed donuts, 3 jelly donuts, 3 with sprinkles, 2 chocolate. If a donut is selected at random, 1, what's the probability that it's either a glazed donut or a chocolate donut? Again, it's an or probability. So you're counting how many? How many glazed? 4. How many chocolate? 2. Any donut that is both glazed and a chocolate? Doesn't say so. If there were, you will overlap. I mean, you'll subtract them, the ones that are double counted, but it doesn't say that. So what we're going to do, we just put it over the total, which is 12, and you get an answer of 6/12, which is exactly 1/2, which gives us 50%. Okay, exactly half of the donuts are either chocolate or glazed. So that wasn't too bad. All right, now question 9 and 10. Let's read carefully. Actually, it should also say 11. All these 3 questions refer to this chart. So we have year that some condominiums were sold and how many bedrooms they have. Okay, 1 or 2, 3, 4, 5 or more. Number of bedrooms. Yeah, kind of weird. I haven't seen a condo that has 4 or 5 bedrooms. Kind of weird. Okay, but anyway, let's look at the question. Number 9. What is the probability that a randomly selected condominium sold by the agent, not an angel, right, had a 4 bedrooms? Okay, so how many? We got 4 bedrooms, 133 that were sold total. Talking about total 4 bedrooms out of the grand total of 258 altogether. So you read it from the table and you set up that as a fraction. Notice this is similar what you did in chapter 1, I think, when you talk about those tables. Remember we looked at tables, contingency tables, and wrote the percentages. This is very similar. So it's 133 out of 258, which gives us 52%. What is the probability that a randomly selected condo sold by the agent was a 3-bedroom sold in 2015? Okay, so very convoluted. So let's try to understand what are we looking at. So we're looking at the year 2015, and we look at the 3 bedrooms that were sold in that year. Okay. So let's look at the year 2015 and 3-bedroom. So there are 18 out of the total of 258. So it's that category. So we do 18 divided by 258 and get the answer of about 7%. There's a little typo right here, which will be fixed once you get your review sheet. All right, so it should say 7%. Okay, so that would be choice B. Alrighty, number 11. What is the probability that a randomly selected condo sold by the agent in 2016 had 3 bedrooms? So now the sentence has changed sort of the direction, so we need to look at specifically 2016. But it's not, you see, it doesn't say of all the condominiums that were sold. It was talking about condos that were sold in 2016. So these are the ones that were sold in 2016. And the total of them is 54. Let me write it over here so you could see it. All right, so it's 54. And the ones that had 3 bedrooms were 16. So it's 16 out of 54. So it's not out of the total because it was referring to the year 2016. All right, so it's 16 out of 54. That gives us the answer of 30% about. Okay, let's move on. A teacher asked a class of 45 science students about the other classes they are taking. 25 of the students are taking math, 11 are taking English, and 8 are taking both math and English. What is the probability that a randomly selected student is taking either math or English? Again, it's an or probability, so success would be either here or there. So we got math, 25, English, 11, right? 11. And we need to subtract an overlap. Let me maybe write it like, in a proper way. So you see here, instead of giving us a table, they're giving us in a sentence. So probability that it is a math or English is going to be probability that it is math plus probability that it is an English or taking an English class minus probability that it's both math and English. So this is direct application of addition rule, and remembering that you don't want to double count the same students twice. So we got 25 math, 11 English, and remember that part of 25, there are 8 of them who are taking both, and part of the 11, there are 8 that are taking both. So in reality, when we add 25 to 11, we're counting the same 8 students twice. So that's why you have to subtract 8 ones to get us the correct count for successes. All right, and then the whole thing is going to be divided by how many? The total is 45. Okay, so that gives us probability of 62%. Okay, so you add subtract divided by 45, you get 62% as your answer. Question 13, we are taking 2 fair coins, not one, or not coins, 2 fair dice, a toss. 2, not 1. What is the probability that the sum of the numbers is 7? All right, now here, I think the easiest way to do this, since there are 2, is to write down all the possibilities. All right, so now check this out. When you have 2 dice, all right, there are 2 of them, then each one, there's 1/6 probability that there's going to be one particular number. The total number of combinations that are possible is going to be 6 for the first die multiplied by 6 for the second die. So there are 36 different possibilities. And when I say possibilities, it's like 1 and a 1, 1 and a 2, 3 and a 4, 5 and a 6. Altogether, there are 6 for one die, 6 for the other one. So there are 36 different possibilities. And we're looking for the one that has a sum of 7. How can we get a 7? Well, we can do 1 plus 6, or 6 plus 1. We can do 2 plus 5 and 5 plus 2. And finally, we can have 3 plus 4 and 4 plus 3. It doesn't matter the order because, you know, the first one can be a 3 and the second one can be 4 and can be vice versa. Well, the total is 7 here. So out of these 36 possibilities, 6 of them gives us 7 as a sum. So therefore, the answer is going to be, how many? 6 out of 36. Which reduces to 1 over 6, and as a percentage, it gives us 17%. So it's a little harder question, but you know, once you list the possibilities, then you know you can figure this out. So there are 36 possibilities, and 6 of them gives us the sum of 7. Number 14, if the weather reports say that the probability that it will rain today is 20% and the probability that it will rain tomorrow is 50%, assuming it should say that the weather forecasts are independent from one another, but I already mentioned that all the questions that you will see in this modulus do not deal with the dependent events. So when it's talking about 2 days, we do probability that it rain on the first day multiplied by the probability that it's going to rain on the second day. So probability that it rains on the first day is 20%, write it as a decimal. And then the probability that it's raining on the second day is 50%. And then you multiply those two and you get 0.10 or 10% chance. So basically, you are multiplying those two probabilities because those 2 days are independent. Okay, so you can write those as a fractions, but I suggest that you write them as decimals and then multiply those two to get the answer of 10%. Number 15, a bag contains red, blue, white marbles. So here we go again. The probability of pulling out a white marble is 2/5. What is the probability of pulling blue or red marble? I mean, this one I think is not too bad at all. So it's asking us what's the complement of the probability. So it's simply the rest. Okay. So writing this out, you know, using just like operation, you can do it like this. You don't have to. You can right away select an answer of 3/5 and you will be fine as long as you understand it's the other piece. Right, if 2/5 are the white marbles, and the rest are going to be the other colors. That's why the answer is going to be 3/5. All right, let's go to some graphical representation. So we've been doing a lot of probability questions. So now let's go ahead and talk about some graphs. Here you see a histogram. Which of the following data represents this? Is just simply, can you read? Do you know what the histogram is and its properties? So if you look at this picture table and if you match it with the diagrams, you'll see that this is the answer, right? So 0 to 9 has a frequency of 10, 10 to 19 has a height of 8, and you go through it and you'll see that that's the only one that gives us what we have. Alrighty, so that's just reminding you what we have learned, right? We'll talk about histograms. Next one is the box plot or the box and whisker plot. It's two names for the same thing, all right? So they're used interchangeably, okay? And to review this, when you look at the box plot, this is talking about the number of text messages, okay? This is the highest one. This is the lowest one. The line right here in the middle is the median. That serves as the halfway, all right, halfway, the median. Remember, half of the people texted less than 12, the other half texted more than 12. And in addition, what we guys covered in this chapter is something that's called a quartile. So there's a Q1 and this one is the Q3. And the way it works is that anything that's between the minimum and Q1 covers the 25% of the data. Then the other 25% is going to be inside this box. Then another 25% is to the right of the median inside that box. And then the top percentage is going to be right here. So the Q1 and Q3 are basically just separating your whole into more pieces. So you know how, let's say we draw the a rectangle. And if we divide it in two, we get half, like that. And we call this 50% and 50%. So simply, if you divide this in another, each half and half, like that, then you get 25% into each quarter, correct? I mean, this is basic, you know, elementary school idea of fractions and percentages, right? So we know that. We're comfortable with this. The box plot is a little bit it's a little more than just that. It gives us a visual idea where the data is. So do not get like confused with the fact that when you think of this, all of them partition have to be equal. When we talk about data, your data can contain whatever number of points, numbers, but then it gives us the region where you'll find a 25%, 25%, 25%, and 25% of different distribution. Okay, so keeping that in mind, let's go through this and see which one is false and true. So what is the minimum number? Well, this one I think is straightforward. Which of the following is not true? Half of the students send between 2 and 8 messages. So let's go ahead and look. 2 and 8, that's not a half. So that's immediately not true. But let's look at the other ones and just double check that we understand that that's actually true. The 8 to 14 right here, this is the two 25s together. This is 50. We call that a middle 50% or the interquartile range, IQR. This is what that middle is. C, half of the students send between 12 and 20. Well, that's actually also true because between 12 and 20, you got 25 and 25. So that's also 50. And the other half is 2 and 12. That's also true. Well, I should have used a different color just so you can see that that's also 50. That's actually what the median is. Remember, median divides things in twos, 50-50. Now we just have more other 50. We also have this one as being 50 as well. Right, inside the box, the interquartile range. So it gives us different 50s. We also get the top 25 and the bottom 25%. 19. According to the plot, what score represents the first quartile? That's 8. That's where you can also make a note. That's a bottom 25%. So that means the bottom 25% of the students scored, not scored, but text 8 messages or less. Which of the following is not true about the box plot right here? 8 represents the first quartile, yes. 20 represents the median, yes. 20 represents the maximum, yes. 14 represents the mean, what a nonsense. Why mean? Nothing was says about the mean. All right, that's false. No mean on the box plot doesn't give us location of the mean at all. And E, 14 to 20 represents the top 25%, and that's true. 14 to 20 is the top 25%. Okay, so these are a nice series of questions that will help you understand the box plot. That everything you need to know in our class about the box plot are covered there. 21. The box and whisker plot shown below represents a monthly salary distribution of two companies. Which of the following measurements are the same for both companies? If you look at the picture, what is the same? It's this little line, and that line represents the median. Question number 22 is the chart that you've studied in class of how to calculate the standard deviation. A standard deviation is a measure in statistics that tell you how do data deviate from the average. Where are the data located on average? So this is talking about the math course, and it's talking about the fear or anxiety towards mathematics. And it looks like on an average, actually we're not given what the average is, but we could calculate it. Yeah, it doesn't tell us what the average is. But by the way to calculate the average, you will need to add up all these numbers, right, and then divide them by how many students, which is 10. But this one is computing the standard deviation. So the formula for the standard deviation is here. You've seen it also in the lesson, I think 3.5. They calculated for us the difference of the squares from the mean. So the only thing we need to do is to add them all up and divide it by the square, or divided by n minus 1. So if you add this, the sum is going to be 16.172. So when you calculate the standard deviation, you take that number and you divide it by n minus 1, which will be 9. Because that 10 numbers minus 1, and then you take a calculator and you take a square root of that. Standard deviation is never a negative number. Never. Never. Okay, it can't be negative because it measures the distance from the mean, and the distance is always positive. So if you do the arithmetic here on your calculator, you'll get the answer of 1.34. All right, so the other questions that are remaining here, they all deal with something that's called an empirical rule. An empirical rule tells that if we know that the distribution that we're looking at is normal, which is for all of the question it will be true, then we have 68% of the data falls within one standard deviation. So when you make one step from on a standard deviation to the right and to the left, you get 68% of all the possibilities. If you make two steps, you get 95%. And if you make three steps, you cover everybody, almost 99.3%. So it's not too bad, trust me. It's just for you being able to understand what that's saying, and that's what these series of questions will help you to, will guide you through it. So we have a light bulbs that are normally distributed. On average, they last 400 hours, give or take, with the standard deviation of 75. Okay? So it says about how many bulbs out of 5,000 will last between 325 and 475, but those numbers fall exactly here. You see, 325 and 475. So your answer when you talk about these questions is always going to be some kind of percentage first. Okay, so you see it's 325 and 475. Those are exactly one standard deviation. You see how the standard deviation is 75 hours? So if you add 75, you get, I write like this, plus one standard deviation, you get 475. And if you subtract one standard deviation, you get 325. By the way, this is a good way to review the meaning of a standard deviation. If you take a randomly light bulb, right? You grab it, its average lasting time is 400 hours. So when you say standard deviation 75 hours, that means on average, okay, on average, it's going to last either 75 hours more or 75 hours less than what's expected. You see? And more importantly, if we know that distribution is normal, we'll know that 68% of the light bulbs will be exactly between 325 and 475. Then 95% will be 2 standard deviations and so on. So that gives us a pretty good idea of what to expect. So here the answer is going to be 68%. But of how many? Well, it was chosen that 5,000 is the amount that we're looking at. So you will go ahead and multiply it by 5,000. So sometimes that question just asks you to find what that percentage is, but sometimes you need to apply that percentage to a particular sample size, which is 5,000. So if you multiply, you get an answer of 3,400. More importantly, you need to understand is that you got to use those percentages, all right? The percentages is what will give you the answers. Let's do more because, all of them are about that. We get something about, it's a lot to read, but do not get thrown off with that, okay? A popular new magazine wants to publish an article, how much Americans know about geography. They devised a test that lists 100 cities in the U.S. that were referenced over the previous year. Each respondent must guess the state in which the city can be found. Each correct answer earns 1 point for a maximum of 100. The score from a random sample of 5,000 test takers were normally distributed with the mean 62 and a standard deviation of 12. So you see a lot of blah, 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 but the most important part is at the end, is that the average is 62 and the standard deviation is 12. All right, so that means that on average, the score will be 62, give or take 12. And that's asking us for 95%. Essential 95%. So, 95% must be 2 standard deviation from the mean. So what does that mean? 2 standard deviation. You do 62, you add 1 standard deviation, and then you add another standard deviation, and you get 62 plus 24. That would be 86. All right, that would be the right side. And then you take 62 and you subtract 12 twice. So that gives you 50 minus 12. That would be 38. That's it. All right. If it's 95, you go 2 times. If it's 68, you go 1 time. And if it's 99.7, you go 3 times. 3 steps. And the step is your standard deviation. That's why the answer is A. Almost there. The heights of 3-year-olds have a mean of 97.5 centimeters and a standard deviation 6.9. What percentage of 3-year-old girls' heights are between 83.7 and 111.3? Notice it's talking about, again, percentages. So it's got to be one of those. So let's go ahead and get rid of the ones that are not part of the empirical rule. And then we have to kind of like add and see how many times do we have to add the standard deviation to get the percentage. So let's check. 97.5. Let's grab our calculator. Let's add 6.9 and see if we're going to get 111. All right, so 97.5 plus 6.9, that gives us 104.4. Okay, so it's not 68. Let's add another 6.9. That gives us 111.13. Jackpot! Here we go. We added 2 times. 2 standard deviation means 95%. Done. By the way, you want to say, what about the other side? Well, if the question was designed to give us that percentage, if you subtract it twice, you're gonna end up with 83.7. So you don't have to. You're just gonna add. That's fine. Another empirical rule. You see, they're not too bad. They're pretty nice ones to do, right? You got it, and then, you can do a bunch of those. U.S. Tennis Championship, blah, blah, blah. Speeds of the player, normally distributed. The average is 99. Standard deviation is 14. What percentage of players serves between 85 and 113? Similar question. Get rid of those. And let's go ahead and start adding. 99 at 14. Okay, so 99 plus 14. That gives us 113. All right, we're done. We added only 1 time. If you added 1 time, it's 68%. All right. Do you understand this? It just gives us the probability of, a percentage of possibilities. So if we know the average is 99 and the player has a standard deviation of 14, then we do expect 68% of the player's serves are going to be between those two numbers because standard deviation is 14. It's what we call an empirical rule. And finally, the last question, the average wait time for club goers lining up for tickets to a popular local club was 20 minutes with the standard deviation of 4. Jake and Dan felt as though they arrived at an unusual, unlikely time because they ended up waiting for half an hour, 30 minutes to buy tickets. Which of the following is true? Well, let's see where they're located. So 20 minutes is the average. Let's see if 30 minutes is more, what percentage it falls. Notice in the choices you do have 68, 95, 99.7. So let's say where they are. 30 minutes. Okay, so let's add 2. So that would be 68% limit. 24, that would be 95% limit. 26, that would be 99.7%. So they are outside of 99.7% of possibilities, which is more than 3 standard deviation. So they are right. They're pretty unlikely. So they should be disappointed. Oh, it's 4 minutes. I'm sorry. Let's go ahead and fix it. Right idea, but I didn't notice. I said 4, but I started writing 2. So let's do it again. So add 4. So it'll give you 24. That will give us 95%. Another 4. That would give us 28. That's 90. Well, that's 68. 1 is 68. This will be 95. And then another 4 is going to be 32. So it's 99.7. You can also visualize it using a normal distribution. Then the middle is 20. Then 68% is going to be 24 or minus 4, which is 16. Then if you do 4 more, that would be 28 and 4. So that's 12. That would be 95% of possibilities of waiting time. They are waited 30 minutes. So the next 4 will end up being 32. And this one minus 4, that would be 8. So that is 99.7. They are right in between 28 and 32. So they're more than 95, but they're less than 99.7%. So they are kind of in the far away zone. That's it. We came to an end. So good luck on your exams. I hope you found this helpful.